Hi everybody, it's Ms. Lorenz here. I'm going to talk about lesson 11. This time we are using our standard algorithm to divide fractions. So remember we've come about the standard algorithm by solving problems and figuring out what we do with the denominator of our divisor with the original fraction that we start with. And so we're going to go through all these problems based on what we've already figured out in the previous lessons. All right, so here we go. First of all, we're just evaluating these initial expressions. 2/3 times 27, all of these are multiplication problems. So why don't I just have you pause your video right now and just correct your work. I just want to remind you of something. When you have a whole number like this 27, it's best to put it over 1 so that when you're multiplying, you remember that you're multiplying straight across, numerator times numerator, and denominator times denominator. And then when you get down to this one, E, remember that in order to multiply fractions here, you have to change that mixed number to an improper fraction. All right, so right here, pause the video and correct your work. All right, we're going to go on. All right, so here's what we figured out in the previous lessons. To divide a number n by a fraction a over b, we first multiply n by b, and then we divide the product by a. And so there's two ways here that we can see that written correctly. It's correct to say that n divided by a over b is the same as n times b divided by a. It's also the same to say that by saying n divided by a over b is the same as n times b over a. So now we're going to apply that to some problems. 8/9 divided by 4, well, we're going to think of 4 as 4 over 1. So it's 8/9 divided by 4 over 1, but we're going to change that to a multiplication problem and multiply this second number by the reciprocal. So it becomes 8/9 times 1/4, which leaves us with 2/9. 3/4 divided by a half becomes 3/4 times 2 over 1, or 3/2, also known as 1 1/2. 3 1/3 divided by 2/9. Remember, we have to change that 3 1/3 to an improper fraction, 10/3. And then we're multiplying by the reciprocal of 2/9. So we're multiplying 10/3 times 9/2, and we get 15 over 1, or 15. D, 9/2 divided by 3/8. Where did I do this one? Right here, 9/2, we're going to multiply by the reciprocal, 8/3. Notice that I'm canceling out factors in all of the problems that you see here. So in this particular one, you can say I've canceled all the factors because I know there are groups of 3 in 3 and 9. There are groups of 2 in both 2 and 8. So by canceling factors, I end up with a really nice multiplication problem. 3 times 4 is 12, and 1 times 1 is 1. So 12 over 1, or 12, is our answer. And then lastly, 6 2/5 divided by 3. 6 2/5 becomes 32/5. And 3, of course, I'm going to write that as 3 over 1. So we have 32/5 times 1/3, because, of course, we're multiplying by the reciprocal here. And we're left with 2 2/15. All right, number 4. After biking 5.5 miles, Jada has traveled 2/3 of the length of her trip. How long in miles is the entire length of her trip? So I want you to look at the strip diagram that I drew just to see if the diagram visual helps you. We know that the entire length of her trip is what we're trying to find here, and that she has gone 2/3. So I've marked the 2/3 section of the strip diagram as 5.5. And now I know if I take 5.5 and I divide it by 2 or multiply it by a half, then I can get the value of each of these thirds. And so that's what I did here. I took 5.5 times a half. So 5.5 became 11/2, and I'm multiplying that by a half, and I get 11/4. So I know that each of these thirds is 11/4. And if each of these thirds is 11/4, then this one is 11/4 as well. So now I have 3 groups of 11/4, which is 33/4, and 33/4 as an improper fraction is 8 1/4 miles. All right, and the last one is the grape juice problem. Really, I just kind of want to see what you were thinking about the grape juice problem, which one you think is the most contaminated when you transfer tablespoons of grape juice into the pints of milk. hopefully you showed your reasoning and you have some sort of a diagram to back that up. All right, so that's it. Thanks for listening, everybody. I hope that helped.